Okay, so good afternoon everybody. So today this is going to be a introductory session on what an embedded systems is all about and how exactly the characteristics of embedded systems can be understood, how to differentiate an embedded system and a non-embedded system. All these things are going to be clarified today. So it is going to be an introductory session. So with this session, probably students will be able to and you would be able to probably recognize an embedded system easily. And with this probably we can take it forward easily. So the agenda of this entire session is all about knowing what is a system, knowing what is an embedded system, and then certain examples of embedded system, and finally the characteristics of embedded system. All these will come together and this will make this session complete. So first of all, what is a system? That's the first point that everybody would like to answer. What is a system? Or human body is a system. The computer that we have, or the projector that I am using right now, or the laptop that I am using right now is a system. So what it does, it is very simple. It will accept an input, it will process it, it will give the output. This is the system. So taking this as reference, would we be able to define what an embedded system is? That is the next step that we need to think of. There are experts in this field who have already defined what an embedded system is, and few of them have been captured here in this slide, where the first one says that it is any system other than a desktop system. It is not meaningful. Let us skip it for now. The second definition says that it is a combination of software and hardware, which is again slightly confusing. So let me skip it as well. The third one, where it says that there will be a programmable computer, but it is not a general purpose computer. This is slightly relevant to our expected definition. The first definition that we saw was it is any computing system other than a desktop machine. So you mean to say that whatever other than desktop system can be regarded as embedded system? No, this is not perfect. Second case, combination of software and hardware. Then my desktop itself will come into that category. My desktop has got a hardware, where hard disk, lot of hardware components are there, and then operating system is the main software that goes and sits in there, and that itself will be an embedded system there. So all these definitions are not complete is what I feel. So let me put it in the way that you guys can easily understand. Let me take a simple example. Let us take a pacemaker. So what is a pacemaker? A pacemaker, when the heartbeat of a particular patient goes low, if there is a pacemaker fit inside, the pacemaker will make sure that the patient is not dying and it will increase the heartbeat on time. That is it. This is what the pacemaker is all about. So what are we giving as input to this pacemaker? We will set the heartbeat count 72 as the input value for this pacemaker. It will keep on monitoring the heartbeat of the particular patient, and whenever the heartbeat goes low, this will take a contracting action which will bring the heart to the working condition again, that is expected condition again, that is nothing but 72 beats per minute. So that will happen with the help of pacemaker. Then coming to the air conditioner, this is another example which needs to be taken right now. This air conditioner, what we are doing, we will just set up the expected temperature. Say for example 18 degrees centigrade is what I expect. I will set it up. When there is an external variation in the temperature, if the day is so hot, what will happen? Automatically there will be an influence in the internal room temperature as well. So there is a tendency towards rising the temperature inside the room. Now the air conditioner will keep on monitoring the room temperature that we have set 18 degrees centigrade. Whenever there is a tendency of the room temperature getting varied, it will take the contracting action so that the room temperature will remain in the expected level of the user or the consumer. So this is an embedded system. So from these two examples, we can easily spot the definition of an embedded system. An embedded system must have a controller inside which can accept a process variable as an input. Process variable can be anything. It can be a heartbeat, it can be the temperature or anything. And then it should keep on monitoring for the set value. Once it varies, it should take the contracting signal for it to be brought back to the normal working condition. The examples of embedded system are very vast, right from the moment we get up in a day to the time that we go to sleep, that we go to the bed. We are living with embedded systems. And that's the best point that we can spot right now. I have got a set of examples here, like we are using a washing machine which is an embedded system. I have shown a dish antenna, a set-top box can be taken for that matter, ECG, my PDA, my mobile phones, my tape recorder, a lot many things that we come across in the day are all embedded systems. Why do we call it as embedded system? They are all going to do a single task forever. Embedded systems are meant for doing a particular task forever. For example, washing machine is meant for only washing the clothes and it will not control the room temperature. I am using a digital camera here as an example which will not control the room temperature. It is meant only for taking photographs or videos. Only for that matter it can be used. So an embedded system definition has been given some time back, but now how exactly one can spot a device as an embedded system or a non-embedded system is based on the way it behaves. Very simple. If I take my projector that is right above my head, it is an embedded system because it is going to do only one task forever. It will not control the room temperature. But if I take my laptop or a desktop system that I have, though it has a combination of the software and hardware, it cannot be regarded as embedded system because it can do multiple tasks. I can play game in my laptop, meanwhile I can send a mail to my friend as well through that laptop. I can type a Word document and I can listen to the music that I love. This all can be possible with a laptop. It is called as a general purpose computing system, whereas my embedded system is a specific purpose computing system. This is the major difference that anybody should know. Well, having seen the example or definition of embedded system, the next step would be to see the characteristic of an embedded system. So when you take any equipment or any device, there will be certain characteristics that have to be definitely looked into. First thing, simple function. What is simple function? It will do only one task at a time. For example, I have a digital camera, I cannot use it for washing my clothes. It can be used for only taking photographs. Single function. Finished. Tightly constrained. Well, what do you mean by constraint here? Can I have a digital camera of weight around 15 kg? Can I have a mobile phone of weight around somewhere around 10 kgs? All these are constraints. So I should have constraints on the cost, first thing. I should have constraint, first thing, on the cost. Second thing is on the size. Third thing is on the power. So constraint means cost should not be too heavy. If I am asked to buy a mobile phone worth 15 lakhs, I will not buy it because it is too expensive for me to go ahead and buy it. But if it is cheaper and at the same time if it is efficient, I will definitely buy it. So cost is the most important factor that we need to take into consideration for any embedded system. Second point, power. I have a phone, I have an embedded system. If it drains charge every 10 minutes, will I use it? No way, I will have to connect it to the charger all the time, which is not possible and which is not fair. So power should also be perfectly saved since most of the embedded systems are all battery operated. So that is the biggest problem with it. One second. So we have the third characteristic of an embedded system is real-time behavior. So what is real-time and what is real-time behavior? Very simple. I have a pacemaker in my heart. Assuming I have a pacemaker in my heart. Will I tell my pacemaker when will I get my heartbeat going low? No way possible. If I can predict that, I will have to go to the hospital for doing it. And then I have a BMW car which is very luxurious as we all know. And I have a car braking system there. Will I tell the braking system that I will apply brake by this time so that be ready for accepting my braking pressure? We will not be able to say it because we never know when we will apply brake. So real-time behavior is something that we never know what is going to happen, but the system should be ready to accept the input and process it and to give the exact output that is required. So in putting it in a better way, I can say like this: it is logical correctness of an operation within a deterministic deadline, which means when we apply brake, the operation should be logically correct, which means the car should be stopped or the vehicle should be stopped. But if it stops after 200 meters, it is not a correct operation. So it should stop in that instance perfectly. Precise and accurate operation is what is required, and that is what is referred to be as a real-time and a reactive behavior. And then complex algorithms. So I am shooting this thing through a digital camera. So what happens? I use a digital camera. Is it easy to build a digital camera? Not at all. It has got a lot of complex algorithms inside. Is it easy to build a projector? No, there are a lot of microcontrollers which are sitting inside for it. A lot of codes are getting inside. So complex algorithms will be there for any embedded system. That's a point to be noted. And then user interface. Well, this is very simple. I give you a mobile phone. which is not very easy to operate. It has got so complex setups for it to be used. For the user to store a number, he has to spend about 5 minutes of his time in searching on all the options. Will you use it? For playing a song, you need to spend about 3 minutes of your time to select the particular song. Will you use it? No way. The user interface should be as simple as possible. For example, if I take a Nokia mobile, it will be the simplest example. It is very easy to use for even an illiterate to go ahead and use that Nokia mobile. It should not be complex. The user interface should be friendly. Our ATM machines are another example that we can take here right away. They are all very simple to operate. I just insert my card, options will come, I take my money out, come out happily. So user interface should be simple as much as possible. That's the point. Next thing, we have got multi-rate as one of the characteristics. What do you mean by multi-rate here? Again, taking the digital camera or a braking example, car braking system as an example, I might go on the speed of 50 kilometers per hour and I can apply brake. And I might go on the speed of 70 kilometers per hour and I can apply brake. I might go on the speed of 120 kilometers per hour and I can apply brake. So the system should be ready to work in any rate, any environment. For car braking, I told the speed. Now for the digital camera, I can put like this. I can put an example like this. Simple. I want to take a color photograph, it will still permit. I want to take a black and white photograph, it can still be used. And finally, I want to make a motion picture. That is also possible. So multi-rate is one of the abilities of any embedded system. Finally, we have manufacturing cost that I have covered already in constraints area, and power also we have covered in the constraint area. So these are all to be taken into consideration when you are trying to build an embedded system. Altogether, I can simply say, if you have all these characteristics, you can call it an embedded system. That is a sweet way of putting it out. So what next? So how an embedded system can be diagrammatically shown? That's again simple. Acquire, analysis, acquire, analyze, and then give the output. This is what basic any system's work is all about. Input, process, output. That's it. I am acquiring, I will analyze, and then I will give the output. Same is the case for embedded system also. I can acquire input from sensors, switches, or any other input equipment. I will acquire it, I now analyze it. This is where the programmers will come into play. And they will program, they will analyze, they will process using their microcontrollers or processors. And then that will be sent to display for viewing, or that can even be used to drive actuators, alarms, indicators, or anything. On the whole, this simply says that we have got input, processing, and then output. All these together forms an embedded system. So by now you could have got an idea of what an embedded system is and what are their characteristics. So by now you should be able to identify. If I show you a laptop, will you be able to tell if it is an embedded system or not? It is not an embedded system because it is not a specific purpose device. It is a general purpose device. If I show you a LCD projector and then if I ask you if it is an embedded system, is it an embedded system? Absolutely yes, it is an embedded system because it is doing single function characteristics fitting there. So like this, a student should or you should go ahead and identify spot embedded systems. This can serve as a better introduction for anybody to take further learning process in embedded systems. Thank you.